All right, let's jump right in. In this explainer, we are going to break down everything you need to know about testing the density, you'll also hear it called unit weight, and the yield of fresh concrete. This is a big one for your ACI Field Grade I exam, and my goal is to get you ready for both the written and the performance parts of it. So here's our game plan. First, we'll cover why we even do this test. Then, we'll run through your equipment checklist, which is super important. After that, we'll walk through the step-by-step procedure, then we'll tackle the math, and finally, we'll test what you've learned. Okay, so first up, why do we even bother with this test? Why is it so important on a job site? And more to the point, why is it so important for your exam? Well, you can think of it as a fundamental quality check that tells us a ton about the concrete we're about to use. You might be looking at that one bucket of concrete and thinking, what can this possibly tell me about a whole truckload? Well, it turns out a whole lot, actually. This test is our window into the entire batch. It gives us vital information on the concrete's properties and its consistency, and it's a really fast way to make sure the concrete that showed up on site is the exact same concrete that was designed. Here's the crucial point. Density is a massive quality control check. If that number changes, it's a red flag. A drop in density could mean a few things, maybe higher air or water content, or that the proportions are just off. This usually leads to what we call over-yielding. Now that sounds great, right? Getting more volume than you paid for, but it could come at the cost of strength. On the flip side, a higher density might mean you're under-yielding. All right, let's get into the gear. This is your equipment checklist for the performance part of the exam. And let me be clear, knowing your equipment, inside and out, is totally non-negotiable. And here it is, the whole setup. You've got your measure, a scale, a strike-off plate, your tamping rod, and a mallet. Now, for your performance exam, it's not enough to just know what they are. You have to know their specific requirements, which is exactly what we're about to cover. Okay, I need you to pay very close attention here. This is an exam hotspot for a reason. These numbers are prime targets for the written test. You absolutely, positively have to remember the tamping rod dimensions, the mallet weight, and, listen up, especially the vibrator frequency. 9,000 vibrations per minute. I can almost guarantee you'll see a question on that. Get these numbers down cold. Now it's time to walk through the procedure. Step by step, exactly how you'll need to do it to pass. Remember, the examiner is watching every single move you make. So the very first decision you have to make comes down to the slump of your concrete. This is a key decision point. It's pretty simple. If the slump is over 3 inches, you must use the rotting method. If it's under 1 inch, that really stiff stuff, you must vibrate. Now, for that gray area in between 1 and 3 inches, you get to choose. You can use either method. For the performance exam, the name of the game is precision. You're going to fill the measure in 3 equal layers. And listen, this is key. It's 3 equal layers by volume, not by height. So think 1/3 full, then 2/3 full, then all the way. Rod each of those layers 25 times. And please, don't forget to grab that mallet and tap the sides 10 to 15 times to release any trapped air bubbles. Now look closely at this technique. To do it right, your rod has to go through the layer you just placed and penetrate about 1 inch into the layer below it. This is absolutely critical. It's what knits the layers together and ensures you don't have any voids. Okay, the final physical step is striking off. And trust me, there's a very specific technique for this. You can't just scrape it flat. That sawing motion is a specific requirement you have to demonstrate. It's what lets you properly finish the surface without pulling out aggregate or creating voids. This sequence shows you exactly how it's done. You start by covering about 2/3 of the top. Then you pull back with that sawing motion. After that, press down and push forward to finish it off. And for the final touch, you incline the plate and make a couple of sweeping passes to get it perfectly smooth and level. Okay, take a deep breath. The physical part is done, but you're not finished yet. Now we have to run the numbers. Let's break down the math. You will need a calculator for your exam, and you really need to know these formulas by heart. First up is density, or unit weight. The formula looks a little formal, but it's really simple. It's just the mass of the concrete divided by the volume of the measure. So you weigh the bucket full of concrete, you subtract the weight of the empty bucket, and then you just divide that number by the bucket's known volume. That's it. Here's a perfect example, pulled right from your manual. You take the mass of the filled measure, subtract the mass of the empty one, that gives you the net mass of the concrete. Then divide that by the volume of the measure, in this case 0.250 cubic feet, to get your density. I'd recommend you practice this calculation over and over until it's second nature. Next up is yield. So what is it? It's the total volume of concrete that a batch actually produced. In the real world, this is critical. It tells the contractor if they got the volume of concrete they paid for. And where do you find the total mass of all the materials? You'll get that right off the batch ticket. Relative yield makes things even simpler. Think of it like a score. It's a direct ratio comparing the actual volume you just calculated to the volume you were supposed to get from the design. A relative yield of 1.00 is a perfect score. It means you got exactly what was ordered. If you get a 1.05, that means you got 5% more volume than expected. So let's just walk through the math for both. For yield, you take the total batch weight, divide by the density you just measured, and that gives you the yield. Then, to get the relative yield, you simply compare that actual yield to the design yield. Make sure you can perform both of these calculations. And hey, here's a cool trick. Let's say your air meter breaks on site. It happens. You can still calculate the air content using the density. The formula is the theoretical air-free unit weight minus your measured density divided by that same air-free unit weight, all times 100. The easy way I remember it is big number minus little number divided by big number times 100. It's a great backup to know. All right, you've seen the gear, the procedure, and the math. Now it's your turn. Let's run through a couple of questions straight from the ACI study guide to see what you've learned. These are exactly the kinds of questions you can expect on the written exam.
Okay, first question. What is the minimum frequency of the vibrator used in this test method? Go ahead, pause if you need to. Think about it. Remember that exam hotspot? The answer is 9,000 vibrations per minute. Did you get it?
Next one. When you're rotting, how many layers do you need to fill the measure in? This is a big one for the performance exam. How many equal layers? The answer is 3 equal layers. And remember, that's by volume. So the real question is, are you ready to prove it? Look, you have the knowledge now. You know the procedure, you know the formulas. The key at this point is practice. Go back, review this explainer, study your workbook, and master this section for your exam. Because you're not just learning steps for a test, you're learning how to ensure the quality and integrity of the concrete that literally builds our world. You've got this. Good luck.